So we're going to keep going with our knowledge, and in this lesson we're going to be covering most of some of the harder problems in the lab. It's not necessarily new concepts, it's putting everything together to solve problems within the lab. So we're going to be able to solve an equation with fractions. We're basically going to learn how do we get rid of the fraction so that I can write something in quadratic form and solve it with an answer. Then we're going to look at applied problems and quadratic forms and solving by substitution. So if I have something in fractional form like this, my x's are in the denominator. The first thing I have to do is clear out all those denominators. So I'm going to multiply every term by x times x minus 1. Because when I do that, the denominators are going to cancel. So x minus 1 is going to cancel with x minus 1, and so I'm going to have 4 times x. The 9 has nothing to cancel, so it's going to be 9 times x minus 1. And in the second one over here, the x's are going to cancel, but not the x minus 1. Then I'm going to distribute and get it into standard quadratic form. Once I get here, you can use any method to solve that you want. You could factor, you could use the quadratic formula, you could do completing the square. It is totally up to you. In this case, it does factor, which means that my answers are 7 over 9 or negative 1. You can pause the video here and go ahead and complete this with the quadratic formula, and you should still get the same answer. To solve applied problems, this happens when we're dealing with questions like this. With the 1 3/4 hour, he's rowing his boat upriver and he comes back. The rate of the current is 3 miles per hour. How fast does he row? So what I do is I read everything through one time before I even take notes. Then I'm going to think about the variable. How fast does he go? I'm going to let x equal the rate of the current because he's rowing with that current, and I'm going to make a table. The distance upstream, he goes 5 miles upstream and 5 miles downstream. The rate of the current, if I'm going upstream against the current, I have to go at least 3 miles per hour before I'm even going to stay in the same place. That's why it's x minus 3, because whatever your speed is, you're losing 3 miles per hour to that current rate. So that distance is rate over time, so I get 5 over x minus 3. Now on the way back, the current is working in his favor and it's adding 3 miles an hour to his speed because he's going with the current. So that would be 5 over x plus 3. So I'm going to do my upstream plus my downstream equals the total time that Cody is rowing. I converted 1 3/4 over to 7/4. Now I'm going to worry about getting rid of these denominators so I can solve. So I'm going to use the same method I saw in the previous example where I multiply by all the denominators. Things are going to cancel as I do that process, and then I'm going to need to go ahead and distribute. This is a great time to pause and distribute those values into the parentheses and then check your work. Once I distribute all of my information through, I'm going to combine my like terms. 60 minus 60 is 0, but 20 plus 20 is 40x. Now I'm going to work on getting this in standard form. Once it's in standard form, you can use any method to solve. Quadratic formula, factoring, completing the square, any of those will work. This one happens to factor. So I can factor it, set it equal to 0, and then solve to get negative 9/7 or x equals 7. You can take some time to pause this video at this point and go ahead and try the quadratic formula here. Here's another example. 2 chefs are preparing a banquet. One chef could prepare the banquet in 2 hours less than the other one. They can complete the job together in 5 hours. How long would it take the faster chef if he was working alone? So we're going to read the problem carefully. We're going to get all the information we can think of, highlight those numbers, assign a variable, and we're assigning it to the slow chef because we have the information about one can do it in a time less than the other. That means x minus 2 would be my fast chef. So I'm going to set up that table. Rate, time together, when I divide those, the time divided by the rate, that's what gives me the fractional part. 5 divided by 1 over x would be 5 over x. 5 divided by 1 over x minus 2 would be 5 over x minus 2. When I add those times together, that equals the whole job. So when I take that equation, I want to get rid of those denominators. So I'm going to multiply everybody by x times x minus 2. Then I'm going to cancel out and distribute. So take some time, let this digest, and go ahead and distribute. Now I can use any method to solve this: the quadratic formula, factoring, completing the square. Once I get down to here, the square root of 104 can be broken down into the square root of 4 times the square root of 26. The square root of 4 is 2, so that reduces. Then everyone here is divisible by 2, so this does simplify down to just 6 plus or minus the square root of 26, which we can guesstimate at 11.1 or 0.9. Read very carefully in the lab and determine where they want you to round, and if they don't tell you to round, then you want to be sure you enter the entire radical. Then we're going to state our answer, and we can check it by checking our work. So we can solve some problems with radicals by writing them in a quadratic form. What does that mean? It means if I want to solve this problem with the square root, I can get everything over to the left and the square root on the right, and then I can square both sides. This forces you to FOIL. You cannot do 2x squared minus 1 squared. You have to FOIL that out. But if you notice, it gets rid of the square root, so then now I have a quadratic that I can use any method to solve. I chose to factor this because it's a little faster than the quadratic formula, but you could also use the quadratic formula here. The extra step you must do when you have a radical is check your answers. So I'm going to go back to the top, and if I did the square root of 1/4 plus 1, that would not equal 2 times 1/4. So that answer choice is eliminated, and the only possible answer is x equals 1. You gotta check these when you're doing them. That's the most common mistake in the lab, is that people don't plug in and check both answers. Now, I can solve other quadratics by what they call substitution. These are kind of complicated in the lab. So what I'm going to do is I'm going to take these equations and basically put them into a form where it's a standard form equation. So if I let part A, let's say u is x squared, I can recopy this as 2u squared plus 5u minus 12. In B, if I make u x plus 5, then I can get it into a standard quadratic form. In C, if I say u is 2/3, I can get that into a standard quadratic form. Here is my hint, guys. The middle term determines what u is. Look at all of these. 5x squared, u is x squared. X plus 5, u is x plus 5. X to the 2/3, u is x to the 2/3. That's a great quick way to figure out what you're using for the substitution. Now to solve it, once you create the substitution, it solves like a regular quadratic. So in this case, this factors. It's the very last step where you have to go back because u is 1/9, not x. So I'm going to plug in what I said u was and then solve. So I'm going to take the square root of both sides, and I get 4 answers. I have to check all 4 answers to make sure they work. Most of the time they do, but it's a good habit to go ahead and check them. In Web 2.0, you can type it directly in: 9 times 1/3 to the 4th power minus 37 times 1/3 squared plus 4, and that should give you 0. Here's another example. Again, it's not a quadratic, but I can look at that middle term, that x squared, and I know what my u is. Then I rewrite it as a regular quadratic, and I can factor, complete the square, or use the quadratic formula. Here I did the quadratic formula. Let's try something different. Once I get it solved down to u, I have to go back in and plug in my x value. So I have u is 2 plus the square root of 2, but it was x squared. So then I have to take the square root of both sides, and it's a really ugly answer, but it's right. So in the lab, don't get freaked out when you see this. This is totally possible. This is kind of a step-by-step process for how you can do the substitution. You can definitely print the screen and or copy these down. You do want to always check them by plugging them in, even though the square root of the square root one would be difficult. You could still do that in the Web 2.0 calculator. Here, that middle term, 9 times what, that determines your u value. You solve the quadratic like normal. You get it down to the u's. Then I'm going to go back and say, oh, u was x plus 3. So then I'm going to solve those for x by subtracting 3 from both sides. So those two are really my answers. Then I'm going to plug them back into the original equation to make sure they're both true. Same thing here. I need to get everybody to the left first, and then that middle term is going to tell me what my u is. Once I have that, I've got it in standard quadratic form. I can factor, I can complete the square, I can do the quadratic formula, and I get my value for u. Then I have to go back and say, well, u wasn't x, it was x to the 1/3. So to solve x to the 1/3, you're going to cube both sides. So I'm going to get negative 1 over 64 and 1. I'm going to plug them back in, and they both work. So the substitution can be tricky. You definitely need to watch this video more than once, because I don't go back and cover how to factor or how to do the quadratic formula, because you've had previous videos on those. But go back, rewatch it, pause it, digest the steps as they happen until you can follow along. Do not go into the lab until you are comfortable with these example problems.